Okay, good morning students. We have already started Science 1. We have started with chapter Refraction of Light. In order to link whatever we are going to study today, I will take a brief revision of the previous part, and then in continuation we will start talking about other aspects of refraction. Basically, refraction of light is change in the path of light when light enters from one transparent medium into another when it is made incident obliquely. What I mean to say is, observe this diagram. Let us assume this is the medium or interface between two media. This particular surface is separating medium 1 and medium 2. I am drawing a normal, that is the perpendicular at the point of incidence. This is the incident ray made incident at point of incidence. When it enters from one transparent medium into another, what happens is generally the light travels in a straight line. That is what we assume, because light is an electromagnetic wave. It has to travel in a straight line. It is not deflected by electric or magnetic field. So, if we assume it to travel along a straight line, what happens when the medium changes? The ray of light either bends towards the normal. This is the case when this is rarer medium, this is a denser medium. So, I am labeling this as ray number 1, which will travel along ray number 1 dash. Now, what will happen if I make the ray incident in the second medium, which is denser? I will label here, this is rarer medium, this is denser medium. If I make ray incident in the denser medium, labeling the incident ray 2, when it enters from denser to rarer medium, it bends away from the normal. In this case, the original direction of ray was this, but the ray will travel along 2 dash. So, in any case, now what is the condition for this? The ray has to be incident obliquely, it should not be along the normal. In this case, there is a change in the path of light, but what happens if I make the ray incident along the normal? When oblique incidence is there, there is change in the path of light. When ray is incident along the normal from rarer to denser or denser to rarer, in both the cases, the direction of the light remains the same. In this case, what we have studied before, Snell's law, we have studied 3 laws of refraction. Out of that, the third law was called as Snell's law. It says that for a given pair of media, the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. See, I am repeating the statement, break it into smaller parts, try to understand the concept. According to Snell's law, the ratio of sine of angle of incidence, that is angle of incidence is this here, angle of refraction is this. Sine ratio, all of you know, opposite side upon hypotenuse. So, that ratio of sine of angle of incidence to the sine of angle of refraction is always constant. The same constant is called as refractive index. The second part of this statement is quite clear, that is, you do not need to learn the statement by heart. You can remember the mathematical part, write it in statement form. What is this ratio of? Ratio of what? Sin I to sin R is constant. But when this condition is obeyed, provided you have the given pair of media. That is, last time I also told you that if you have this as air and this as water, then the ratio comes out to be 1.33. If you change water to glass, then the ratio becomes 1.532. If you replace the glass by diamond, the ratio becomes 2.42, etc. If you change one of the media, even then the ratio of sine of angle of incidence to sine of angle of refraction changes. For a given pair only it is constant. Now how it is written? If I consider this as medium 1 and this as medium 2, then the refractive index is written as 1n2. In some cases, in 10th standard textbook, they have used letter n, but in some cases, the letter n is replaced by this Greek symbol mu. But you don't have to deal with that. In 10th standard, you will be using letter 1 and 2. How it is to be read? First, what does n stand for? N stands for refractive index. Refractive index of whom? Of the second medium. With respect to whom? First medium. So, if I want to write refractive index of air with respect to glass or glass with respect to air, then I will write ANG, refractive index of glass with respect to air. If I want to write opposite, refractive index of air with respect to glass, then I will have to write G first, then N and then A. If I want to write refractive index of glass with respect to water, it will be WNG, refractive index of glass with respect to water. Now there is a hitch in this particular law. What does the law say? We know. But now for this incidence, what you will be doing? The incident ray is along the normal, so angle of incidence is 0. The refracted ray travels along the normal, so angle of refraction is also 0. If you are going to use this particular formula, then 1 and 2 will be sine 0 upon sine 0. What is ratio? Sine ratio of angle 0, it is 0. This number is not defined. You cannot have a number, or you don't define a number with 0 in the denominator. So in such a case, how to find the refractive index of the media? This can be proved mathematically, but we are just going to deal with the formula because the proof is not there in the 10th standard syllabus. 1 and 2 is speed of light in the first medium upon speed of light in the second medium. One thing I forgot to tell you, if first medium is air or vacuum, the refractive index like this is called as absolute refractive index. Sometimes this will be mentioned as NG. If A is not written, you have to assume that A is here. In such a case, the first medium is not air, so such a refractive index is called as relative refractive index. Coming back to this, in this particular situation, when the incident ray is traveling along the normal, the refractive index is given by ratio of velocities of light in the first medium to the second medium. It is same as wavelength of light in the first medium to wavelength of light in the second medium. In refraction, always remember one thing. When light travels from one transparent medium to the other, which are the quantities that change? Quantities which change are 1. Speed, second wavelength, and third is intensity, or if you consider wave, it is amplitude. Make a note of this thing, students, because many times multiple choice questions are asked on this part. And quantity which does not change. There is only one quantity which does not change even if light enters from one medium to the other, and that is frequency of light. All these things we had discussed before, some points were remaining. So I have completed the revision. Now I am going to go further with the numericals. On this formula, what formula you are supposed to know? 1, 2, and the third one is sin I upon sin R. These are the formulae which you will need for solving numericals. There are few numericals solved in the textbook, there are few numericals given for practice. There are few numericals which are application type. So we will be solving all types of numericals first and then going to the further part, that is total internal reflection and certain phenomena like why sun appears to be red, dispersion of light, etc. So after this, I will solve 2 or 3 numericals first and then we will go to the later part of the chapter. Okay, before that, to find easier way, I will do one thing. What is the relation between one n 2 and 2 n 1? We will take some application type questions which have already occurred in the board exam. So, derive relation between refractive index of second medium with respect to first and first medium with respect to second. I am assuming that this is medium 1 in which speed of light is v1. This is medium 2 in which speed of light is v2. How you will be writing 1 and 2? That is refractive index of second medium with respect to first. Just now we said it is v1 upon v2. Now I want to write same type of equation for the second one. 2n1 will be given by, can you think? Here for refractive index of second medium, we wrote the velocity in the first medium in the numerator. So I will have to write here v2 upon v1. Next part, I will start with this 1 and 2 equal to v1 upon v2. If I divide the numerator as well as denominator by v1, it is not going to make difference dividing numerator and denominator by v1. What you get is 1 and 2, left hand side is not going to change. Numerator I am dividing by v1. Denominator also I am dividing by v1. This will cancel out and it will be 1 upon v2 upon v1. Now observe on the board, what is value of v2 upon v1? It is nothing but 2n1. So instead of this, substitute this. Therefore, 1 and 2 equal to 1 upon 2n1. Cross multiply. Multiply here 1 and 2 into 2 and 1 equal to 1. This is the relation which sometimes can be asked in the exam as 1 mark question, 2 mark question, etc. This can be a multiple choice question also. Now I am extending this particular concept to the third medium. Observe. It's quite easy to understand, we start with medium 1. A ray of light is incident on medium 1. It enters medium 2. Let us say this is the normal. This is rarest medium, rarer medium, and we still have one more medium here. This is medium 3. Let us assume V1 is the velocity in the first medium, V2 is the velocity in the second medium, V3 is the velocity in the third medium. What type of question can be framed? 1 and 2 into 2 and 3 equal to ... They might ask you to fill in the blank here. So what you are going to do? Write formula for 1 and 2. 1 and 2 is what? V1 upon V2. What is 2 and 3? It is V2 upon V3. That is equal to, what cancels out? V2 will get cancelled. So you will get V1 upon V3. By definition, what is V1 upon V3? It is 1 n 3. That is refractive index of third medium with respect to first. It is going to behave as if the second medium is not present. It is going to, the light is going to behave in such a way that second medium is absent. Directly you are using medium 1 and 3. Such type of questions can be asked in the board exam. With all these background, now we will solve simple numericals and then we go to the application type numericals after that. I don't know, I will have to write the numerical in short. These are very simple ones, provided your understanding of refraction and the formulae is proper. So first numerical I am writing in short. If speed of light in glass is 2 into 10 raised to 8 meter per second, find refractive index. I am using short form R for refractive, I for index of glass with respect to air, or wording may change. Find absolute refractive index of glass, means with respect to air. What is given? Speed of light in air equal to 3 into 10 raised to 8 meter per second. Now board expects you to solve the numerical in a particular manner. There is a particular format by which you are supposed to solve the numerical. Maximum weightage, I won't say marks, but if you solve a numerical in a particular format, the impression on the examiner is good and it becomes a habit for you for higher studies. So observe, like in geometry, what is given, what is to prove, formula, etc. that you write. Same is the way for this. Now what notations we are using? I am using first solution, I will write here, solution. In that, first part to be written is given. What is given? Speed of light in air, that is given 3 into 10 raised to 8 meter per second. What is the second data given? Speed of light in glass. Notations you remember now. V stands for speed or velocity. The subscript stands for the medium. So speed of light in glass is 2 into 10 raised to 8 meter per second. What is to be found out? Means most of the times this is observed that students keep the numericals aside immediately, they don't even read it properly. Actually, if you are able to get the data from the numerical and if you know the formulae or the relation between them, it is very simple to solve. What is to be found out? Refractive index of glass with respect to air, means in notation form you want to find out ANG. Now think about what is the relation between the three quantities. So next heading will be formula. What is the formula? ANG equal to VA upon VG. ANG, refractive index of glass with respect to air, equal to velocity in the first medium upon velocity in the second medium. Do you have the values? Observe, there are certain numericals in which you will have to identify the values by some other formula. But here I have both the values given directly. So next comes calculations. In calculation, write the formula again and just substitute the values. 3 into 10 raised to 8 meter per second upon 2 into 10 raised to 8 meter per second. Observe what things cancel out. 10 raised to 8 is going to cancel out. Meter per second is also going to cancel out. And if you divide it or keep it like this, 3 by 2 or 1.5. Many times it is observed that here unit is written as meter, but refractive index is a physical quantity which does not have any unit, and hence write answer ANG equal to 3 by 2 or 1.5. Generally, put a rectangle for the final answer. This is the way you are supposed to approach. To understand, I have taken the easiest one. Now we will be going to a little bit difficult numerical, that is application of whatever formulae you have learnt up till now. So first I will write the numerical again, like I wrote it for this time, and then we will continue with it. Right, 1. Problem 2. If refractive indices, I will write absolute refractive indices. Again, RI stands for refractive index of glass and water are 1.5 and 4/3. Okay, observe. The absolute refractive indices of glass and water are 1.3 and 4/3. What will be the values of WNG and GNW? Speed of light in air is equal to 3 into 10 raised to 8 meter per second. Now this data is given, but how you can approach it? It can be approached in two different ways. See, from this data, refractive indices and the speed of light, you generate speed of light in glass and in water, and then use the formula V1 upon V2. So that is the way we will solve first, then I will give you a shortcut method. So solution 1 I will write here, don't get confused. Solution 1 is based on the basic principles. So that I am trying to do it. What is given? Given is A and G equal to 1.5, A and W equal to 4/3, and VA is equal to 3 into 10 raised to 8 meter per second. What is to be found out? To find W and G equal to what and G and W equal to what? Formulae. Now there will be many formulae needed. So I am just writing the formulae. The first formula is for A and G, that is VA upon VG. From this I will generate a formula Vg equal to Va upon A and G. Just shift this. Second formula I know A and W equal to Va upon Vw, implies Vw equal to Va upon A and W. The third formula that will be needed is W and G equal to Vw upon Vg, and the fourth formula G and W equal to Vg upon Vw. What are the calculations? I am giving you a hint for this. Try to do the calculations by yourself as homework. From these formulae, first find Vg. I am just substituting the value and keeping calculations for you. It is 3 into 10 raised to 8 upon 1.5. What all you need in this? Vg already we have generated from the first formula. I have substituted value of Va and A and G. Vw equal to 3 into 10 raised to 8 upon, what is the value given? 4/3. So this I will write answers here because they are direct. Here 3 goes up, so it is 9 into 10 raised to 8 upon 4, that is 2.25 into 10 raised to 8 meter per second. Now substitute these two values in this formula and get the answer. W and G equal to Vw. Now what is Vw? 2.25 into 10 raised to 8 meter per second upon 2 into 10 raised to 8 meter per second. Carry out the calculations by yourself. G and W, 2 into 10 raised to 8 upon 2.25 into 10 raised to 8. So this is going to cancel out. This is going to cancel out. Answer comes out to be 2.25 upon 2, that is 2 ones are 2, 1, 2, 5 equal to 2 upon 2.25, that is equal to, you will have to calculate this. Check whether you are getting the answer close to 0.9 or something, approximately equal to 0.9 I will write. Check this answer. So in the next lecture, we will continue with the numerical and go to the next concept. Thank you.